first step when you do a bond problem is to draw a timeline of the bond that we're working with. We see here that this is a 4% semi-annual coupon bond. The interest rate, which is the yield to maturity, will jump from 5 to 6% today. What is the percent change in the price of the bond today? Because the question is what's the percent change and not a dollar change, we can make up any par value we want. So it is easy to work with $1,000 in my opinion. So I'm going to use a par value of 1,000. That means that the semi-annual coupon amount will be the coupon rate times the par value split up into two pieces because it's a semi-annual bond. The bond matures 20 years from today. Therefore, there are 40 periods, with each period paying $20 coupons and $1,000 being paid on the last date. We want to find what the price would be under two different rates. We have a yield to maturity of 5% split up into two because yield to maturity is an APR. And then going to 6% yield to maturity divided by 2 to get the 6-month rate. Remember that yield to maturity and the coupon rate are APRs. So when it's semi-annual, you have to make these adjustments. Now we will use the formula for percent change in the price to answer the question. The formula for a percent change in the price is the price at the end minus the price at the begin. So begin I'll define as when the interest rate was 5% over the price at the beginning. Remember, it's the change from after the effect minus before the effect divided by the price before the effect. So that's the setup. Let's get to work with finding the price under both interest rates. So when the yield to maturity is 5%, we can plug all the numbers from the timeline into the present value formula for a bond. Or we can use our financial calculator to do this formula for us, starting with the N is 40, the interest rate is 2.5, we want to know the price, which is the present value, the PMT is 20, and the FV is 1,000. So put that into your calculator now. 40 is the N, 2.5 is the interest rate, 20 PMT, 1,000 FV. Solve for PV, and you will get 874.4861. Hold on to more places past the decimal point than what we want in the end. Now let's find the price of the bond at 6%. We can either replace all of these discount rates with 3%, go ahead and write that down just so that you can see that clearly, what I'm talking about. Or use the financial calculator. Now the nice thing about using the financial calculator is that I don't have to start over again. I just need to change the one thing that is changing, which is the interest rate is 3%. And then we recompute a new price. So go ahead and put 3 as the new interest rate, solve for price, which is the PV. You'll get 768.8523. Next step, percent change in the price. Let's recall that this is the formula for percent change in price. The price at 5% is the beginning price, and the price at yield to maturity of 6% is the ending price. So after the interest rate changes, price is 768.8523, that will mean that the price is going down. Important to remember that fact about bonds, that when interest rates go up, prices go down. Go ahead and put that formula into your calculator. You will get negative 12.08%. Then we scroll up to find that option, and we see there it is. All right, let's go on to question number 2, which is very similar. We have a bond. This time we are given the par value, and that's important because the options here give a dollar change, not a percent change. Let's diagram the cash flows again. We have a $1,000 bond. We know that we'll pay $1,000 at par. At maturity. The coupon rate is 6.4%, and it's semi-annual. So I'd split it in two because it's semi-annual. It has a 9-year maturity. Because it's semi-annual, we will have 18 periods. At each period, $32 is paid as a coupon. And remember, the $1,000 is also paid at maturity. The yield to maturity currently is 6.9%, but then it tells us that interest rates fall and yield to maturity decreases by 0.8%. This means that we need to find the price of the bond. A yield to maturity of 6.9% on a semi-annual basis, so you split that in two, and then it's going down by 0.8%. Now notice that because yield to maturities are APRs, a quoted change in the yield to maturity will also mean this is for an entire year. So this means that the 6-month rate is actually going down by 0.4%. And then the change in the price will be the price at the end minus the price at the beginning, where end is the price after the yields fall and price is before they do. Price at the beginning is before they do. All right, so that's the plan. We need to find what the price is under both those scenarios. All right. So again, we're going to do the price at the yield to maturity of 6.9%. let me do the formula one more time. In the remaining questions in this video, I will skip writing the formula mostly and just write the steps in the financial calculator, because the financial calculator is calculating this for us in an easier way. Notice that instead of writing out what 6.9% divided by 2 is, I just write this because I know that I'm going to carry on more digits, and the less amount of calculations you have to do in the interim, the better for not making a mistake. So we want to find the price. Again, the way we can do that without plugging it directly into the formula is to just put these numbers into your financial calculator. We want to find the price, which is the present value. The PMT is 32. And now when you are putting your numbers in, at this point, all I need is this timeline I drew. I don't need to go back to look at the question, because the timeline says it all now. So put 18 for N, 6.9 divided by 2 is the interest rate, 32 PMT, 1000 FV, solve for PV, get 966.8888. Alright, now when the yield to maturity goes down to 6.1%, if I were to rewrite the formula, I would just replace all the 6.9s, or 0.069 by 0.061. However, the financial calculator makes all of that much easier in that I just have to replace the interest rate with 6.1 divided by 2, and then that will give me a new PV. So go ahead and put in 6.1 divided by 2 and your interest rate, solve for PV, and you get 1020.5433. Going back to our plan, we're going to take the change in the price after the interest rates fall. We can verify that we're doing things correctly, or at least that the numbers make sense, because when interest rates fall, we know that the price of the bond has to go up. And we see there's the answer, 53.65. Now be very careful with the signs, because we see fall by 53.65. It's very important that you understand that the price must go up, not down. We can see that in the numbers here, and we have to make that check that conceptually it's correct that we are saying that the price has to be going up. Because again, when bond prices fall, then that means that the yield to maturity has gone down, and vice versa. Alright, let's go on to question 3. Question 3 is a different kind of problem because it asks what is the coupon rate of this bond. Now let's just remind ourselves how we find the coupon payment. We find the coupon payment by multiplying the par value by the coupon rate, and then divide by the number of payments per year. Now, if we had all of these three values, we could find the coupon rate. However, in this problem, we are not told what is the coupon payment. So we have to do some more work. we have to find the coupon payment, and then we can plug it into this formula to then find the coupon rate. As always, just make the timeline of the cash flows that you know of the bond in this problem. Now, pay very close attention that this bond pays coupons quarterly, has a maturity of 8 years, meaning that there are 32 periods. We are not told the coupon rate, that's what we want to know, and we are not told the coupons directly, so I'm going to represent the coupons just with the letter C. The par value is 1,000, so I'll write that at the end. We're told that the yield to maturity is 12%. Because it's quarterly and yield to maturities are APRs, the quarterly discount rate will be 3%. And we are told that the market price of the bond is $850. Now the term market price is the present value. So now we have all of the components for a coupon bond except for the coupon payment, but because we have all the others, we know that we can find the coupon. Right, now in this question I will skip over writing the formula, but we could plug all the numbers into the formula and then solve for C, or just using the financial calculator, put the values that we see here. Very important to note, I'm making the PV a negative. The PV must be the opposite sign of the FV. If you have a hard time remembering, think about buying the bond. If you buy the bond, you will pay $850 and you will receive $1,000 in 8 years. So they have to have opposite signs. And the payment will be a positive number because it has to have the same sign as the par value, because you receive a coupon as well as receiving the par value. They have to be going in the same direction. So we see that the quarterly payment is $22.64. So this is our C. We're going to plug it into the definition of coupon payment given a coupon rate. So the par values was 1,000. There are, 4 payments a year. So therefore the coupon rate is 22.643 times 4 divided by 1,000, giving us 9.057%. And we see there's our answer, A. Let's go on to the next question, which is just about the same, just some different numbers. We have a semi-annual bond this time. Matures in 12 years, so there's 24 periods. It sells for $840. Has a yield to maturity of 9%, so we'll split that in half because it's semi-annual. Has a par value of 1,000. We don't know what the coupon rate is, but if we can find it out, we don't know what the coupon payment is, but if we find that out, we know we can find the coupon rate. Okay, we can plug in everything that we do know about the bond into the financial calculator, remembering to make the PV negative. Solve for payment. FV FE is 1,000. So 24N, 4.5 interest rate, 840 negative PV, 1,000 FE sulfur, PMT. That's 33.9621. Then the coupon rate would be twice that divided by the par value, giving us 6.792%, and we see there's that answer in B. Question 5. This question has lots of parts to it, and as always, make the timeline, and then you'll find that it might not be as bad as you first thought. It tells us that in 2016, so when I have problems that give years and not periods, I find it easier to first write the year on the bottom of the timeline and then figure out the periods. 2016 semi-annual coupon bond that matures in 2036, so maturity is here, has a $1,000 par value. Traded at 1070. So the term traded means that this is the market price. So the price in 2016 is 1070. And its coupon rate is 6%. So the periods, semi-annual, the coupon payment is $30 every 6 months. Again, the way you find the coupon is the par value times 6% coupon rate split in half. So I got the 30. Now, let me also put in the maturity. So we have 20 years passing semi-annual. So the total of 40 periods. Now, we want to know what is the price of the bond in the first day of 2017. So this is what we want to know. Basically, what's the price of the bond 2 periods in? Now, what rate will we use to discount? We don't know what the discount rate is now. In 2016, but we know that in 2017 the discount rate will be whatever the rate was in 2016 minus 2% divided by 2. Okay, how did I get that? It says the yield to maturity on the bond is 2% less than a year ago. So the change in the yield to maturity will be 2%. So that's the change in the yield to maturity. But remember, yield to maturities are APRs. This is a semi-annual bond. That means that the 6-month rate goes down by just 1%. So if I can find the rate in 2016, I can find the rate in 2017, and then I can price the bond. And when I price the bond, it's going to be the present value of all the cash flows that will come after someone would buy the bond on January 1st or beginning of 2017. I guess the problem doesn't say it's January 1st, but we just can pick the same date within each year so that whole years are going by between each date. Alright, well let's get to work with first finding this. So in the financial calculator, I will put in the total periods, 40. I want to know what's the interest rate. The PV is negative 1070, the PMT is 30, and the FV is 1000. It's worth pausing here to note that PV is negative, PMT and FV are positive. If you have a hard time remembering that, consider if you were the investor in the bond, you would have to buy the bond at 1070 in exchange for receiving coupon payments of $30 every 6 months and $1,000 at par. So payment and FV must have the same sign. PV has to have the opposite sign. So go ahead and put that into your calculator. N equals 40. PV equals negative 1070. PMT equals 30. FV equals 1000. Solve for I. Get 2.7111%. Now leave that in your calculator. Let's consider the two things that will change in 2017. We know from here that the 6-month rate will go down to 1.711%. We also know that there's 2 periods less to maturity. There's 38 periods left. So you have to make those 2 changes, and then we will solve for a new price. That'll be the price in 2017. So subtract 1 from the interest rate. N equals 38. Leave everything else alone. Solve for PV. And I get 1357.93, or rounding to 1358. And we see that is option C. This is a hard problem because we have not only the yield to maturity changing, but also there's the passage of time to consider. So 10 years semi-annual means there's 20 periods. It has a par value of $1,000 and a coupon rate of 5%, which means the coupons are 25. Again, the way I got the coupon is I put in the coupon rate, split it into 2 pieces to get 25. Now it tells us that the yield to maturity was 8%, it's semi-annual, so the discount rate would be 4%. And this afternoon, the yield to maturity is going up by 1%, or in other words, the 6-month rate goes up to 4.5%. What's the percent change in the price of the bond? And we're going to use the same formula we've used before. The price at the end of as a result of the change minus the price at the beginning. We need to get the prices under both scenarios here. So at this point, we can use the timeline, see if you can apply the idea from the previous questions here. The interest rate starting out at 4%. We want to know what the price would be. go ahead and put that in your calculator. N equals 20, I equals 4, PMT equals 25, FE equals 1000, giving us 796.1451. Now the interest rate goes up to 9.2 divided by 2, so we will change the interest rate to 4.5, solve for a new price. So go ahead and put I equals 4.5 now, solve for new PV, giving us 739.8413. We have percent change in price now being the price after the interest rate goes up minus the price before the interest rate goes up divided by the price before the interest rate goes up. Oops, reverse these digits here. 0.1451. Giving us negative 7.07%. We look up for the options and we see there it is, it's B. All right, let's go on to number 7. Right now, number 7 introduces, for the first time in this video, capital gain yield. So let's go over what capital gain yield means. I'll abbreviate it with CGY. The meaning of capital gain yield is the price of the bond in 1 year minus today's price divided by today's price. Alright, let's diagram the bond and then we'll plug in values into this formula to get capital gain yield. The semi-annual bond has 12 years to maturity, so semi-annual means 24 periods. Par value is 1000. It sells for 11.25, so that's the PV. The coupon rate is 6%, so 6% of 1000 divided by 2 is 30. The yield to maturity will remain constant, but notice that I don't know the yield to maturity, but I need to so that I can find the price of the bond in 1 year, which is here with period 2 on my timeline, again because it's semi-annual. But if I get the price in 1 year, I can plug it in there. I know the price today, which is 11.25. So if I can find R, then I can find price in 1 year. So let's go ahead and put everything into the calculator. N is 24. We'll solve for I, the 6-month interest rate. The PV is negative 11.25. Remember, PV is always negative if the PMT is positive and the FE is positive. N equals 24. PV is negative 11.25. Payment is 30. FE is 1000. Solve for interest rate, and I get 2.3153. Right, now hold that in there in your calculator because we don't have to redo everything. The price of the bond in 1 year is just the present value of these remaining 22 payments. So with the passage of time, the N goes down by 2. Interest rate stays the same because the problem says yield to maturity stays the same. PMT and FE always stay the same. Now we solve for a new PV. So changed the N to 22. Solve for PV. I get $1,117 and fraction of a penny. Now we plug in all the numbers to this formula for capital gain yield. So the price in 1 year is $1,017,021. Beginning of the year was $11.25 divided by the beginning of the year price. Giving us a change of negative 7.1%. And we see, there it is, option E. It's worth noting with this question, because it's going to come up in future questions, that this was a premium bond because it sells for more than par, yield to maturity stays the same, and the price goes down. Premium bonds must always depreciate over time, even though the yield to maturity stays the same, because in 1 day, even though it's selling for $11.25 right now, it's only going to pay the $1,000 at maturity. Let's do another capital gain yield question. We have a 7% semi-annual bond, so it pays coupons of $35, matures in 10 years, so you have 20 periods, par value of $1,000. Its yield to maturity is 11%, split that in two. The yield to maturity stays the same. What will be the capital gain yield of the bond over this 1 year? So in this problem, we don't know what the price is. In the previous problem, we did know what the price was, but we didn't know what the discount rate is. So we'll have to solve for both of these prices. Plug it into the formula for capital gain yields, and that will give us our final answer. So let's get to work. Price the bond. Let's price the bond at period 0. So at period 0, there's 20 periods remaining. The interest rate will be 5.5% every 6 months. We want to know the price, so that's the PV. The PMT is 35, the FV is 1,000. Okay, put that in your calculator. N equals 20, I equals 5.5, or 11 divided by 2. PMT equals 35, the FV equals 1,000. Solve for PV. You get $760.99. Now when we solve for the price in 1 year, remember that's the present value of all the remaining cash flows after 1 year. And so there's 2 periods less before maturity. So N will be changed to 18. We'll solve for a new PV. Giving us $775 and basically 8 cents. Now it's time to find the capital gain yield. The price goes up over the original price at the beginning of the year of $760. giving us a capital gain yield of positive 1.85%. Okay, we look at the options here, and we see there it is, A. Now in this problem, I want to pause to make you realize that this bond was a discount bond. The reason that we know it's a discount bond is that the price is less than par. Also, we know it's a discount bond because the yield to maturity of 11% is greater than the coupon rate of 7%. So that makes it a discount bond. Discount bonds must eventually appreciate in price, even though the yield to maturity stays the same. We see this here, that it's increasing in price to 7.75. Therefore, the capital gain yield for a discount bond will be positive with yields to maturity staying the same. And that's because even though it's selling for so much less than par now, one day it will pay par of $1,000. Let's go on to question 9. All right, this is our first conceptual problem of the video. The question is, what's true about the risks of investing in bonds? So before I go through the answer, let's just review interest rate risk. A bond that has a longer maturity, all else equal, has more what's called price risk. That means that the price goes down by more because of an interest rate increase. A bond with a lower coupon rate also has more price risk. The reason is that the lower coupon rate means that more of the bond's value is tied up at par and not in the coupons, which are received sooner than the maturity date. So when interest rates go up, the lower coupon rate bond will go down by more than a higher coupon rate bond because the discount rate is being raised by the highest, or more of the value is tied up with a date that's in the future, which means the discount rate will be raised by a higher power. Now, before you think that bonds that have the opposite terms of these must be less risky, you have to also consider that shorter maturity bonds so these are more price risk, have more reinvestment rate risk. So if a bond matures sooner and interest rates go down, you would have to reinvest the proceeds from that bond that's matured into lower interest rate bonds. And higher coupon rate bonds also have more reinvestment rate risk. Okay, so these are not your trivial matters. To really see this for yourself, I recommend actually work out problems and see this for yourself. And look at the percent change in the price of the bond when you compare two that are the same except for maturity and then two that are the same except for the coupon rate. See what happens when interest rates go up versus when interest rates go down. All right, with that background, let's go through this question. Now, when you do conceptual problems, you should do process of elimination. So let's go through each option and see if we can eliminate it and hopefully have only one left over. So A, short-term bonds are the safest investment because they protect the investor from the effects of both increasing and decreasing interest rates. So I just contradicted that because I was saying a shorter-term bond has more reinvestment rate risk, whereas a longer-term bond has more price risk. So you can't escape interest rate, the impacts of interest rate changes by investing in bonds. B, because treasury bonds are considered risk-free. Now that's true, but only in default, meaning Treasury bonds will not default. But if you had to sell the bond and interest rates change, then you won't get par. So Treasury bonds are not free from interest rate risk. C, the earlier the maturity date, the greater the price risk. Well, that's false because it's the later the maturity date, the greater the price risk. D, the lower the coupon rate, the greater the price risk. Yes, that's what I wrote out here. Lower coupon rate, more price risk. So D looks good. Let's just go to E to make sure. E, long-term bonds are the safest investment. Well, that does right away. We know that that can't be right. Long-term bonds have the most price risk. So E is wrong, leaving us D. Indeed, the only correct statement. All right, let's go back to a problem. This one is tricky, but not impossible. In the end, we want to know what's the capital gain yield of this bond from beginning to end of 2018. Now, we're told the bond was issued in 2016. Par value of 1,000, semi-annual coupon bond that pays 6% coupons. But it's semi-annual. So $1,000 times 6% divided by 2 is $30. So it's going to pay $30 every 6 months, right up to the last date. It matures in 2026. So I'm writing the years here. Then it's helpful to write the periods separately. So 10 years passes from 2016, so a total of 20 periods. We are told that on January 1st, 2018, the price of the bond was $10.75. The yield to maturity does not change in 2008, will be the capital gain yield from beginning to end of 2018. So this is the beginning of 2018. 2 periods later will be the end of 2018, which is also the beginning of 2019. It's the same as basically the same as January 1st, 2019. So we want to know what's the capital gain yield going from here to here. So the capital gain yield in this case will be the change in the price of the bond over 2018 divided by the original price. If we can find the price in 2019, we can get the price we can get the capital gain yield. So, but the thing that we don't know is what is the discount rate. So we need to know the discount rate so we can find the price 2019 so that we can find the capital gain yield. So let's get to work. First, let's find the discount rate. Now, in 2018, notice that 4 periods have already passed since the bond was issued. It's actually irrelevant that the bond happened to have been issued in 2016. All that we care about is what is the maturity of the bond at this date, which is actually 8 years to go until maturity. We want to know what the 6-month rate is. The price, let's look at the timeline, is negative 1075. Remember that negative sign when you're putting in price. PMT is 30. FV is 1000. Solve for I. N equals 16. PV equals negative 1075. PMT equals 30. F equals 1000. Solve for I. you get 2.4287. Okay, leave that in your calculator. Now to get the price in 2019, realize that in 2019 you have a claim on all of these cash flows. As of that date. So we have 2 less periods to go till maturity. So find price in 2019, all we have to do is change the n to 14, interest rate stays the same, solve for new price. So put in n equals 14, solve for PV, get 1067.1223. Now we have everything we need for capital gain yield. Remember, the end price minus the begin price. You can verify that this makes sense because because this is a premium bond. Remember, premium bonds must depreciate over time. Giving us negative 0.7328%. Look at our options, and we see indeed we're just round to 2 places. It's E. Alright, let's go on to number 11. Okay, 11 is another conceptual problem. And we'll bring up the things that I've been talking about in a lot of the problems leading up to this point. Again, due process of elimination. If interest rates rise, then a price decrease of a 20-year bond with a coupon rate of 8% will exceed the price decrease of a 20-year zero coupon bond. So the two things that are different, the one thing that's different between these two bonds is the coupon rate. Now recall what I wrote out in question 9. I wrote that a lower coupon rate means more price risk. So if interest rates go down, if interest rates go up, because as interest rates rise, we know that the price will go down, and the price of the 20-year zero coupon bond will go down by more than the 8%. So A is a contradiction of that property. The price decline will be greater for the zero coupon bond, because that's obviously 0 is less than 8. If interest rates rise, then the price decrease of a 20-year bond with a coupon rate of 8% will exceed the price decrease of a 1-year bond with a coupon rate of 8%. So the maturity is the one thing that's different in this one. So this looks good because when interest rates rise, we know the price will decrease. The 20-year bond decrease will be greater than the 1-year bond decrease. So let's hold on to B. Let's check out the others though. C, a longer term bond has more reinvestment rate risk. False. Going back to, if you look back at your notes from question 9, a longer term bond has more price risk. It's the shorter term bond that has more reinvestment rate risk. D, a premium bond must appreciate, and discount bond must depreciate. Now this goes back to what I've been talking about in a lot of the problems up till now. If we plot price against time up to the maturity date, and if this is the par value here, the premium bond must go down to the par value, whereas the discount bond must go up to the par value, because they both will pay par eventually. So premium bonds must depreciate over time, discount bonds must appreciate over time, which is the opposite of what D says. So D is wrong. E, if the yield to maturity fixed rate semi-annual coupon bond with a par value of $1,000 increase from 5 to 6%, the coupon rate increased by 5%. That is wrong. Remember that the par value and the coupon do not change. The only thing that changes, or that could change, would be the yield to maturity and therefore the price, because the yield to maturity is a market-based rate and the price is a market price, and the passage of time. So the number of periods to maturity will have to go down as time passes, but the par value and the coupon don't change. All right, so we can verify that B has to be the right answer. It's the only statement here that's correct. All right, question 12 is our first problem asking for the current yield. Now the formula for current yield is annual coupons divided by the market price, which I've always represented with P0. Now because I'm asking for a yield, I don't need a specific par value, but to do the problem we need to just pick one. And so I'm going to assume a par value of 1,000 like I usually do. Now if the bond is paying $1,000 par, then the market price, because it's selling for 125% of par, must be 1,250. The coupon is 1,000 times 7% divided by 2. But notice that that is the semi-annual payment. The formula for current yield is annual coupons. So to get the annual coupons, I actually will multiply that by 2 to get the annual coupons of 70. Let me just write that out here. We have 2 coupon payments of $35 over the year. The price today is $12.50, giving us 70 divided by 12.50, 5.60%. And we see it's option E. Again, the $1,000 we could have made $100 par, $10 par, $1 par. We would have gotten the same answer because this will be the same current yield per $1 of par. All right, let's go to number 13. This is a new kind of problem because we see that the bond is callable. All right, and this is a tricky problem because, first of all, we have this new concept of a callable bond. If a bond is called, you buy the bond for some price, and your N are the periods to the first date the bond can be called, meaning the issuer can buy back the bond at a fixed price. And you're going to put in the call price here at period N. Now in this case, the call price is $1,200. You will receive the coupons of $11 divided by 2. I'm sorry, not divided by 2 because it's an annual bond. So the coupon will be $110. Now let me just note, the coupon rate is still always the par value. So the coupon payment is always the par value times the coupon rate divided by number of payments per year. Nothing has changed in that regard. But we see the call price and the N are new. Now, we're told that the yield to maturity is 10%. But, well, that's if it's to maturity. The yield to call will be what satisfies this timeline here, what I've drawn. So I need to know what the price is today so that I can find R, because that's going to be my yield to call. Now, the problem's not too nice to us because it doesn't tell us the price, but at least it does give us the hint. We do have to find the price first, so we have everything we need to solve for an I. Now, we're told that if the bond is held to maturity, and the maturity date is 15 years, that the yield to maturity is 10%. The bond, if held to maturity, would make the $110 coupons, and if held to maturity, the investor would get the par value, not the call price. Right now we can find what the price would be, and then we can plug that into the calculator in this step here. So first, let's find P0. So held to maturity, which would be 15 years, the interest rate's 10%. We're solving for price. The payment is 110, the F fee is 1,000. So that part's not new. I get 1076.0608. Step 2. Find the interest rate, and that's the yield to call. So I'm going to take the price I found here, and I have everything I need to solve for the yield to call. Notice that the N will change and the FV will change. So N will be 10, and the FV will change to 1,200, the call price. So let's look back at the timeline here. 1,200, the N in this problem is 10. and then solve for a new I. So change the n to 10, FV equals 1200, solve for I. The answer is 10.91%. And there we see it is option B. All right, let's go on to question number 14. This is another conceptual problem, and it applies this relationship between, it applies this relationship that yield to maturity is composed of two pieces, the capital gain yield and the current yield. Now if you keep this in mind, then we can tackle this problem. We see that the current yield of a coupon bond is greater than the yield to maturity. So we're told that the current yield is greater than the yield to maturity. Now if CY is greater than yield to maturity, but the two sides are going to be roughly equal to each other, that implies that the capital gain yield is negative. And if the capital gain yield is negative, this implies, if you recall our discussion from previous problems and summarized here when I talked about question 11, we see that bonds that are depreciating in value, even though yield to maturity stays the same, have to be premium bonds. The opposite would be true for discount bonds. So we know that this is a premium bond. Right, so this will help us. Right, is this a zero coupon bond? Well, no way, because the current yield is positive. It's greater than yield to maturity. This is a junk bond. That's irrelevant. That has nothing to do with this problem. It might be a junk bond, but it might not be. That just has to do with the probability that the bond will default. C, if market rates remain constant, the capital gain yields will be positive. False. We know that the capital gain yield has to be negative because we've concluded that this is a premium bond. The coupon rate is greater than the yield to maturity. All right, now let's consider what coupon rate greater than yield to maturity means. If the coupon rate is greater than the yield to maturity, then that makes this a premium bond. All right, is that consistent with what we've concluded here? Yes, it is. So D looks good. E, this is a discount bond. False. We already know it's a premium bond, and so therefore D is the only correct statement here. Right, now this is a hard problem. I think all the conceptual problems are hard. But the more you understand about bonds, the more this, of course, will make sense. And the more you understand these concepts, the easier tackling the numerical problems will be. All right, lastly, let's do a zero coupon bond problem. Now, zero coupon bonds are the easiest because it's really just a lump sum problem. We have a zero coupon bond that matures in 20 years. Required rate of return on the bond is 4%. Since we're assuming annual compounding, the discount rate is also 4%. What's the market price of the bond? And that's simply, what's the PV of this lump sum? Where you have $1,000 in 20 years, the par value. So we could, because it's a simple lump sum formula, that's actually quite easy to do with a formula. We can still use the financial calculator. So n equals 20, I equals 4. We're solving for price. It's a zero coupon bond, so there's no coupons, payment is 0. And then the FV is 1,000. giving us 456.39, and there's the option B.